Hey guys, so this is just this week's video of the questions we ran through in the grind. Same thing as always. If I've forgotten any, let me know, but otherwise we'll jump straight into it. Okay, so in this video we're moving a little bit away from the algebra we were doing and trying to introduce a bit of functions or just revise some of the functions stuff that we did before. So what we have here is just a vertex form example sheet. So when we have a quadratic like this, it's usually written in the form x squared plus bx plus c, and we're used to this. From this we can find out what x is by using the minus b formula, so minus b plus or minus square root of b squared minus 4ac all over 2a, where these are just a, b, and c. But another useful form to have a quadratic equation in is something called the vertex form, and that takes the form a times x plus h to be squared plus k. Exact same thing, just written in a different way. You could even say, now that it's not the same a and b, but you can use the same letters if you want. There's no rule against it. The reason I use different ones is because, yeah, they're not the same a and b. So if you have something written in vertex form, you can't plug it into the minus b formula. Okay, but why this is useful is because if we have a quadratic like this, I'll draw it out over here. This here is called your minimum point. You're never going to get lower than this, no matter how hard you try, because these are always going to go this way and this way. But one way to find out the coordinates of this point here, so how far we go across and how far we go down, is by using the vertex form over here. So the coordinates are going to be minus h, k. And this minus here in front of this h is why we always change the sign of the value in here. So let's pretend we had 2x plus 2 squared plus 3. Our coordinates here are going to be minus 2, 3, because we have our minus h over here and we have h over here. If this was minus 2, then we change it to a plus, because it would actually be minus minus 2, and we know that that's a plus 2. Okay, great. So we're just going to take, there's about 4 of these, we're just going to take them one at a time, rush through them. We're not going to rush through them, but they don't take very long. So how we're going to turn this into vertex form, we're going to take this middle term here, and we're going to divide by 2, so that's going to be 6. Then we're going to put an x in front of it and square it, so we're going to get x squared plus 2 times them multiplied together, so that's 12x plus 6 squared is 36. And then how are we going to get from 36 to 32? We're going to minus 4, and we know that this here is just this. So we can do x plus 6 squared, and then keep our minus 4. And that's the whole thing done. So if I get rid of some of this, this is just this, but rewritten in a different way. What is our minimum point here? It's going to be minus 6 minus 4, because we changed the sign of the 1 in the bracket. Okay, great. Next one, take your middle one, divide by 2. And the reason I did this is because it's a minus, but that's not going to let us stop us, so it's going to be x minus 4 this time. And we're going to square that, so that's x squared, and that's 4 times x is 4x, and then times 2 is 8, and then don't forget that minus, so it's minus 8x. And then minus 4 squared is actually plus 16, and then how are we going to get from 16 to 12? We're going to minus 4. Same thing, this here is just this, so that's x minus 4 squared, and then keep your minus 4. Okay, great. Little trick you might have noticed when you're doing it is that when you divide this by 2, you get x minus 4, and then when you square it, you're always going to get this here is always going to be the same as this term here. You're always going to get sorry, that should be x squared there. You're always going to get something that kind of looks like this in the first 2 terms, but is going to differ by the last term, and that's why we're going to have to add on or subtract something. Okay, so third one, and the way this one is different is we have this 2 here. So we can't have this. We're always going to have to just have an x squared. And sorry, I might Let's bring this thinness down a bit. Okay, so we're always going to want x squared, and this is actually 2x squared. So how we're going to get that is we're going to write some big square brackets, and we're going to want x squared. And how we're going to do that, we're going to multiply it by 2. And then how are we going to get minus 4 squared with our 2 here? We're going to multiply it by minus 2x. So 2 times minus 2x is minus 4x. And then how are we going to get this 5 over 2 at the end with this big 2 in the front? Well, we're going to have 5 over 2. So then that 2 multiplied by 5 over 2 is just going to give us 5. Okay, so now we can turn this into vertex form. All we have to do is take this middle one, divide by 2. That's going to be minus 1. Stick your x there. Square it. X squared, minus 1 times x is minus x, times 2 is minus 2x. Then we're going to square minus 1 is just plus 1. And all this is still with our big 2. And how are we going to get from 1 to 5 over 2? Well, we're going to add 3 over 2. And we know that this one here is just that, so we can rewrite that. 2 times x minus 1 squared. Keep the 3 over 2. And now we multiply in our 2. So we do 2 times x minus 1 squared plus 3. And that is the question done. So our minimum point here will be 1, 3. And it's not affected by this 2 here. Because if you remember, if we have a quadratic like this, so this is just our quadratic x squared. If we had 2x squared, same quadratic but just thinner. So same minimum point, but our quadratic is just a little bit thinner, actually twice as thin. And yeah, so this won't affect our minimum point, so we're still going to take the one in the bracket and change the sign. Okay, great. On to the last one. We can't do this, we just need x squared. How are we going to get just x squared? Well, we're going to multiply by minus 3. How do we get minus 6? We're going to get plus 2. So minus 3 times plus 2 is minus 6. And how are we going to get minus 9? We're going to have plus 3, because minus 3 times plus 3 is minus 9. Okay, now we can turn this into vertex form. So divide this by 2. That's plus 1. Throw an x in front. Square it. X squared plus 2x plus 1. How are we going to get back to 3? We're going to add 2. Then we're going to rewrite this first part as just x plus 1 to be squared. Keep the 2. And don't forget about our minus 3 here. So that's minus 3 x plus 1 squared minus 6. Okay, so what is not our minimum point this time, but actually our maximum point because of this minus here. So it's going to look something like this. And our point is going to be minus 1, minus 6. So it's actually going to be down here. It's going to be over here. It's going to be out minus 1, down minus 6. And that is our point. Okay, great. So that's everything you need to know about vertex form. It's not too complicated. They like to ask questions about it, but it's not a huge topic that you need to devote a lot of time to. Just know how to turn it into vertex form, how to get the coordinates, that kind of thing. And yeah, you should be good to go. So on to the next question. Okay, so on to the next question. And the next question is, okay, how are they going to ask something to do with the vertex form in an exam paper? Well, here's what they're going to do. They're going to just ask you to write the function, this function here, 2x squared minus 7x minus 10, in this form here, and we know that's the vertex form. And that's all we have to do. So we know this from our worksheet. We know we just need the x squared. So how are we gonna get just the x squared? We're gonna put a big 2 there. So 2 times x squared is x squared. 2 times what is gonna be minus 7. So minus 7 over 2x is gonna give us our 7x. So 2 times minus 7 over 2x is gonna give us minus 7x. And our minus 5 is going to give us our minus 10. So 2 times minus 5 is going to give us minus 10. Okay, great. So now we can turn this part into vertex form and then multiply in our 2 at the end. So you can see already our 2 is going to be our a. And we're going to multiply that at the end. But let's keep going. Okay, so we take our middle one, divide by 2. So it's going to be minus 7 over 4 this time. We're going to throw an x in front of it and square it. So it's going to be x squared. 7 minus 7 over 4 times x is minus 7 over 4x, and then times 2 is just going to be minus 7 over 2x. And this goes back to what I was saying. Once you square everything out, you're going to end up with what you already had at the beginning. So if you don't, you know you've gone wrong in your multiplication somewhere or your squaring. And so you should always end up, these two terms should always be the same. X squared minus 7 over 2 and x squared minus 7 over 2. What should change and what is different is this term here. So we're going to get something else different here, and then we're going to have to add something on. Sorry, I write something different. So we're going to get, say, we're going to add something on, then we're going to add on minus 2 to get to minus 5. So let's see what that is. Let's see what the red part is. So if we square 7 over 4, or minus 7 over 4, we're going to get plus 49 over 16. And then how are we going to get from 49 over 16 all the way back to minus 5? Well, if you think about your number line, we're going to have 49 over 16 somewhere up here. We're going to have minus 5 down here. We're going to need 49 over 16 to get back to 0, so that's minus 49 over 16. And then we're going to need to minus another 5. So if we add these together in our calculator, so if we do minus 5 minus 42, or 49 over 16 in our calculator, we should get minus 129 over 16. So this is our green part that we added on to get back to minus 5. So now we're going to keep this square here and rewrite it back to what it was. That was x minus 7 over 4 squared, and then we're going to minus 129 over 16. But don't forget, some people leave it like this, and this is where they drop marks. Don't forget your big square brackets here with your 2 on the outside. So now we can multiply in the 2, x minus 7 over 4 squared, and then that's just going to be 129 over 8. And that is your question done. So your a here is going to be 2, your h is going to be minus 7 over 4. And if I can draw, there you go, 7 over 4, and your k here is going to be minus 129 over 8. And why is this useful? Well, the very next question will tell us. It says, hence write the minimum point of f. So we know it's going to look something like this. I don't know where the x-axis is yet. We're going to look for the minimum point. And how we're going to find that? We're going to look at our vertex form over here. So we're going to change the sign of the one in the brackets and then keep this one the same. So it's going to be 7 over 4 and minus 129 over 8. So it's actually going to be here somewhere. So we're going to go out 7 over 4 and we're going to go down 129 over 8. And that's our coordinates. 7 over 4 minus 129 over 8. So write the minimum point of f. That's all we have to do, is write it in this form with your coordinate form with your brackets. That's all you have to do. Job done. Okay. Next part, C, explain why f must have 2 real roots. So I told you anything to do with roots is going to be your discriminant. So b squared minus 4ac. If that's greater than 0, it's going to be real. If it's equal to 0, it's going to be exactly 1 root. And if it's less than 0, it's going to be non-real. But that might take a while. Actually not, they're over here. Like, that's a, that's b, that's c. And you can just plug it in like that. Or a quicker way is just to, like, why have we turned it into the vertex form? We need to kind of take a look at it. Why are they asking us this question? Well, they're asking us this question because we know our solutions or our roots of our quadratic equation where they cross the x-axis. And we know that since the minimum point is below the x-axis, it's down here because this is minus, then it's a positive graph, it has to cross at some point, at 2 points. So because the y-coordinate of the minimum point is below the x-axis down here, that means our quadratic has to cross the 2 points guaranteed. So if our minimum point was here, it'd still have to cross. If it was here, it'd still have to cross. But we know that it's minus, so it's never going to be up here somewhere and not cross. So we definitely know it has 2 real solutions because it crosses the x-axis, definitely. So we can just say minimum point below x-axis, therefore quadratic crosses x-axis, therefore two real roots. That's all you have to say. And then that's your job done. Okay, and so the very last part is write the roots of f of x equal to 0, so that's up here, in the form p plus or minus the square root of q. And so, well, how do we get our roots? Well, we know we have a formula for that. That's minus b plus or minus the square root of b squared minus 4ac all over 2a. And they're giving us a little hint that we can use this because they want the solutions in this form anyway. So they want a number plus or minus a square root. And so they want a number plus or minus a square root. So we kind of know, okay, they want us to use the minus p formula. So all you have here is a is going to be 2, b is going to be minus 7, and c is going to be minus 10. Plug it into your formula and get two answers for x. And always, always, always check your answers. So you'll get 7 for x, say, and minus 2 for x. Just pretend. Then we're going to sub it back into up here into 2x squared minus 7x minus 10. And if that's equal to 0, then you're done the question. If it's not equal to 0, you've gone wrong in your calculation here, or you've put it into the calculator wrong, or something like that. But something's gone wrong, and you need to figure it out. Okay, so that is the whole question done, and that is how they would ask you something to do with the vertex form in an exam question. Okay, so on to the next question. Okay, so on to the next question. So the next question is just a bit of algebra, just kind of gets back to speed to where we were. So I'll run through this quickly. So we're going to try to simplify fully this operation here. So this is actually a division sign. And so how we're going to simplify one fraction divided by another is, first of all, simplify each fraction individually, then divide one by another, and then simplify that division. So how are we going to simplify this fraction here? Well, how are we going to simplify this top line? Well, we can see that that's just the difference of two squares, so it's x minus 3 times x plus 3. And that's going to be over, well, this is a quadratic, so why don't we go ahead and factorize that? If you just do it over to the side here, so 2x times x is going to give us 2x squared. 5 and 3 will give us 15, and that works because 2 times 3 is going to give us 11, and then plus 5 is, or 2 times 3 is going to give us 6, and then plus 5 is going to give us 11. But we want minus 11, so if we just make both of them minus, then 2 times minus 3 is going to give us minus 6, and we're going to minus off 1 times 5 then, so that's going to give us minus 11, so that's perfect. So our two factors are 2x minus 5 times x minus 3. Okay, and then we're going to divide that by, well, here, we can just take the x out. That might work. X plus 3. Yeah, that looks promising because we have a bunch of x plus 3's already. So let's keep it like that and see how that works. And then here, we can actually take out the 2x squared. So we're left with 2x and then minus 5. And that looks promising because we have 2x minus 5 there. Okay, great. If we're dividing fractions, we know we're going to keep this fraction here the same. And we're actually going to swap that to multiply and turn these upside down. So bring that up there and bring this down here. Okay, great. So now we're going to simplify this equation here. How are we going to do that? Well, you know, when we're multiplying fractions, we're just writing them all on one big line. So we're multiplying the bottom by the bottom and the top by the top. And so it's all on one big line. They're all multiplied together. So that means we can kind of cancel some things. And what we're going to, oops, I'll just leave them there. What we're going to cancel is just like terms. So this x plus 3 can go with that x plus 3. This 2x minus 5 can go with that. This x minus 3 can go with that one. And this x can go with that x. And so we're just left with 2x. And that is the final answer. So we've simplified fully this equation here, and we see it's just 2x. So what this is just a fancy way of writing 2x. Okay, great. So on to the next one. It says, find the range of values of x for which 3x minus 2 over x minus 5 is less than or equal to 5. Okay, so first thing that would spring to mind is just to multiply across by the x minus 5 like that. But we know that when we have inequalities like this, if we write this here, a 2 and a 5, we can write 5 is greater than 2, but we can't write 5 is greater than minus 2. So because minus 5 is here, minus 2 is here, we have to swap the sign so that this makes sense. So we don't know whether x minus 5 is positive or negative, so we don't know whether we have to swap this sign. How are we going to get around that? Well, we're just going to multiply both sides of this equation by x minus 5 to be squared. And so that's less than or equal to 5 times x minus 5 to be squared. And we can cancel one of these with one of these and just square out this. So that's x squared minus 5x times 2 is minus 10x, and then plus 25. So we know that 3x minus 2 times x minus 5 is less than 5 times x minus 10x, x squared minus 10x plus 25. And we're trying to find x in this situation. So just to recap what we did, so we multiplied both sides of this equation up here by x minus 5 to be squared. Why did we do that? Well, we know that x minus 5 to be squared is definitely positive. So if we multiply both sides of an inequality here by something that's definitely positive, we don't have to worry about changing the sign. And so that's how we got into this point here. We just squared out this x minus 5 to be squared, and now we cancelled one of these x minus 5s with one of them up here. And now we're just going to multiply everything out, see what we have, and try get x on its own and see what value it has. Okay, so we're going to multiply this out. So 2x times x is going to be 3x squared. 2x times minus 5 is going to be minus 15x. Minus 2 times x is going to be minus 2x. Minus 2 times minus 5 is going to be plus 10. That's going to be less than or equal to 5x squared minus 50x plus 125. Okay, so now we're going to bring everything over to one side, try isolate x. So we're going to bring everything to one side, so we're going to leave 0 on that side. We're going to do 5x squared minus 3x squared. So it's going to be 2x squared. We're going to do minus 50 plus 27. So that's going to be minus 33x. And then we're going to do 125 minus 10, so it's going to be 115. Okay, so we see that x is in the form of quadratic, so we're going to have to factorize or use our minus b. So we can straight away go ahead and use our minus b if you wanted, or we can see if we can factorize and see if it's quick. So 2x times x will give us 2x squared. What times what will give us 115? I think it's something like 23 and 5. So that's 15, yeah. So 23 times 5 gives us 115. And how are we going to get to minus 33 in the middle? Well, if we do 2 times 5, it's going to be 10, and then we just minus that off the 23. So minus, and it's perfect. So 2x minus 23 and x minus 5 are going to be our factors. So 2x minus 23 and x minus 5 are our factors. Okay. So we want to know where 2x minus 3 times x minus 5 is greater than or equal to 0. And the way we can do that is we can write out the cases if you want. So we know that if this whole thing is positive, then both of these have to be positive because a positive times positive is positive. Or they can both be negative because negative times negative is a positive, and that means the whole thing is positive. So we could write that out. We could do 1 is positive, 2x minus 23 positive, so greater than 0, and then the other is positive, x minus 5, greater than 0. Find two inequalities for x, and then case 2, they're both negative. Find two inequalities for x, merge these two, then merge these two, and then merge them all into one big one. A quicker way that I told you to do, and which is useful in this case, is that if we draw out our quadratic, so we know this is the quadratic up here, we know it's going to look something like this because it's going to be positive. I'm not sure yet where the x-axis is going to be, but that's okay. Let's just leave it here, say. Where does the quadratic cross the x-axis? Well, if we let each of the factors equal to 0, so 2x minus 23 is equal to 0, it's going to be x equals 23 over 2, and x minus 5 equals 0, so x is equal to 5. Perfect. So this is 5, and this is 23 over 2. Our quadratic is stretching off this way and this way. If I make this a little squatter, so it's going this way to infinity and this way, so it's getting infinitely wide. And we want everything greater than or equal to 0. So that's everything above the x-axis. So everything this way is stretching off to infinity, and everything this way is stretching off to infinity. So think of like airplane wings. So this one is going this way, and this one is going this way. Greater than or equal to 0, that's your airplane wings, everything on this side. So everything to the left of 5 is going to be everything less than 5. And everything to the right of 23 over 2 is going to be everything greater than 23 over 2. Now we're going to merge these together and write them as 1. One little quick way to do it is to write them on opposite sides. So if they're both on the right hand side, see? So 23 over 2 and 5 are both on the right hand side. If we write 5 on this left hand side and this on our right hand side, and we just kind of move one under the other, then we can smash those x's together, and we have x greater than, or 5 greater than x less greater than 23 over 2. And that is your whole question done. So we found the range of values for x for which this is true. And that is your whole question done. Okay, great. On to the very last question. So we want to prove that the equation px squared minus 2p plus 1x plus 2 has real roots for all values of p, and hence or otherwise write down the roots of the equations. Blah, blah. Okay, so we want to prove something has real roots. Proving roots discriminant, b squared minus 4ac. Okay, we want to prove their real roots. So it's going to be greater than or equal to 0. Okay, what's b in this scenario? B is minus 2p plus 1. So minus 2p plus 1 squared. Minus 4 times a is just p. And c is 2. And we want to prove that that's greater than or equal to 0. Okay, so any minus number squared is just its positive version squared. Minus 4 times 2 is minus 8 times p is minus 8p. We want to prove that's greater than or equal to 0. If we square out this here, we're going to get 4p squared plus 4p plus 1 minus 8p. I want to prove that's greater than 0, so that's 4p squared minus 4p plus 1 greater than or equal to 0. So 2p times 2p is probably going to give 4p squared. 1 times 1, yeah, and then, yeah, 2 times 1 is 2, and then 2 times minus 1 is minus 2, and then minus 2 times 1. So that's going to give us our minus 4p in the middle. So these are our factors, 2p minus 1 times 2p minus 1. Now, we still need to prove that it's greater than or equal to 0. We can't just leave it here. So because p could be anything, we need to prove that this multiplied together is greater than 0. How are we going to do that? Well, a way to rewrite this is just itself squared. So anything multiplied by itself is just squared. And we know anything squared is positive. And 0 squared is obviously equal to 0, so that is why it's greater than or equal to 0. And so that is your whole proof done. We started with our discriminant greater than or equal to 0, so that's how we know it's greater, it has real roots, it's greater than or equal to 0, and we proved it. So we went all the way down to something that is mathematically true without having to check. And so that is how we proved that px squared minus 2p plus 1x plus 2 has real roots for all values of p. Okay, how are we going to write down the roots of the equation in terms of p? So writing down the roots of the equation in terms of p, if we go all the way back up to our start, this is the equation we're dealing with, not this one here. So this is the mistake loads of people make. If we turned b squared minus 4ac down into this quadratic here, but this is not the one we need to find the roots for. This up here is the one we need to find the roots for. So how are we going to find these roots? Well, the easiest way is probably just the minus b formula. So that's a, this here is b, and that's c, and we can write down the roots of the equation in terms of b. This is why they threw this question in though, to try to get you to find the roots of this equation here. So how you would do that is if you wrote 2p minus 1 equals 0, and then p is equal to a half, and same thing for that one, you get p is equal to half. This, it would touch it like this. This is this quadratic up here, not this one. So here we'd actually have minus 2p plus 1 plus or minus the square root of minus 2p plus 1 squared, and minus 4ac, or sorry, minus 4p 2 all over 2p. And well, we know what that is. So b squared minus 4ac is just this, and we actually solved all that. That's going to be 2p minus 1 times 2p minus 1, or 2p minus 1 squared. So 2p minus 1 squared. We know that this square root will cancel with that square. So we're just left with plus or minus 2p minus 1. And the minus minus here will just turn into a plus. So that's 2p plus 1 plus or minus 2p minus 1 all over 2p. So it's going to be, so x can be 2p plus 1 minus 2p minus 1 all over 2p. So that's 2p plus 1 minus 2p plus 1 all over 2p. So that's 2 all over 2p. So that's 1 over p. Or x could be 2p plus 1 plus 2p minus 1 all over 2p. So that's 2p plus 1 plus 2p minus 1 all over 2p. So that's 4p all over 2p. And so that is 2. So x could be 2 or x could be 1 over p. So these are your roots of this equation here. This is where they get you. If you find the roots for this equation, you'll probably get half marks for proving, and then you'll lose out half marks for not writing down the equation. Okay, so that is that question done. Watch out for this little trick here. But on to the next question. Okay, so this is our last question, and it says, find the two values of m for which the following equation has exactly one solution. Okay, so anything to do with solutions, roots, one solution, real solutions, non-real solutions, it's a discriminant. b squared minus 4ac. And so this here is a quadratic, so our b is going to be minus m, our a is going to be 3, and our c is going to be 3. So b squared is going to be minus m squared minus 4 times 3 times 3. So that's going to be m squared minus 36. And if it has one solution, it's going to be exactly equal to 0. So m squared is going to be 36, and m is going to be, watch it now, plus or minus 6. So 6 times 6 is obviously 36, but minus 6 times minus 6 is also 36, because minus times a minus is a plus. So that's the trick that they're trying to get you with there. Okay, part B. Explain why the following equation in x has no real solutions. Okay, no real solutions, so we can do our discriminant b squared minus 4ac. How are we going to do that? Well, we can multiply this all out, so we can square this out, so that'll be 4x squared plus 12x plus 9 plus 7. So it's going to be 4x squared plus 12x plus 16 equal to 0. And then we can do b squared minus 4ac. And we're going to see it's not going to be equal to 0. Another way to do that is, well, we know what this is now. We know this is the vertex form. And again, why this is useful is because we know the minimum point. But if we find out what our minimum point is here, it's going to be minus 3, 7. So it's going to be over here somewhere. Minus 3, and we're going to go up here somewhere, up 7. We know this doesn't, and it's positive. So it's U-shaped. So it goes like this, off this way, and this way. So it'll never get lower than this point. So it'll never cross the x-axis. So we will never have any real solutions. And so we can just say this. So it says explain. So we can just say this. We can keep that. So we can say minimum point above x-axis. Therefore, no real solutions. That's all you have to say. And job done. So those are all the questions you ran through. If I've forgotten any, let me know, and I'll include them in the next video. But other than that, if you can think of any questions, let me know in the next grind. But yeah, so I'll see you guys next time.